Good morning, dear students. In the last lecture, we have seen the equality of matrix, order of matrix, and different types of matrix, right? In this section, we'll try to understand operations on matrix, that is addition, subtraction, and multiplication. You have two types of multiplication. One is multiplication of a matrix with a scalar and matrix multiplication. So we will try to understand that concepts, right? Let's understand first, that is addition of matrices. Here if I want to add A plus B matrix, A plus matrix B, then you should have the order same. Means if A is a 2 cross 2 matrix, then B should also be a 2 cross 2 matrix only. If the order of A and B is not same, then the addition is not possible. So to carry on or move on further with the addition, the first and foremost condition is the order of two matrices should be same, then and then only addition is carried out. So if I am having 1 2 3 4 as A matrix and 5 6 7 8 as B matrix, then I will add the corresponding elements, that is first row first column element of A matrix will get added with first row first column element of B matrix, that is 1 plus 5 I will have 6, 2 plus 6 I will have 8, 3 plus 7 I will have 10, and 4 plus 8 I will have 12, right? So this is how addition of two matrix is carried out. The subtraction is also carried out in the same pattern. Let's just replace plus with minus. So here in subtraction also the order of two matrices should be equal, then and then only you will carry out the subtraction, or else addition or subtraction is not possible if the order of two matrices is not same, right? So here also corresponding element will get subtracted. Means if I want to subtract A matrix minus B matrix, then I will subtract their corresponding element. 1 minus 5 I will have minus 4, 2 minus 6 I will have minus 4, 3 minus 7 I will have minus 4, 4 minus 8 I will have minus 4. So this is how the subtraction is carried out, right? Let's understand multiplication of a matrix by a scalar, right? So if I am having one matrix as 1 2 3 4 5 6 7 8 9, and I am interested in finding 5A, that is 5 into matrix 1 2 3 4 5 6 7 8 9, right? So you can see that this is a scalar quantity, whereas this is matrix quantity. That's why it is called a multiplication of a matrix by a scalar, right? So in this case, this 5 will multiply with each and every element of this matrix. So 5 is a 5, 5 is a 10, 15, 20, 25, 30, 35, 40, 45. This is how multiplication of a scalar with matrix is carried out. Now we'll try to understand some properties related to addition and multiplication of a matrix with a scalar, right? So first property is addition is commutative. To either add A plus B or B plus A, answer will always be same. Another is associative property. If I want to add three matrices, then I can do it in two ways. I can first add B and C, and whatever the result is, I will add it with A, or I can do it in this fashion also. If I will add A and B first and then adding it with C, in both the case my answer will be same, right? Additive identity. Zero matrix or null matrix is the additive identity. If you will add or or 0 matrix with A, you will have again the same matrix A. Sorry, not 0, but it will be A, right? One more is additive inverse, means I can multiply it with -1, right? The importance of additive inverse is if you add the matrix with the additive inverse of that, then you will have additive identity, right? That is 0 matrix. So you can obtain additive inverse of a matrix by just simply multiplying that matrix with -1, right? Let's try to understand the properties associated with the multiplication of matrix by a scalar. First property is, let's say 5 multiplied by a plus b, then I can use distributive property to write it as 5 into a plus 5 into b, right? One more property is that 5 plus 10 into a matrix can be written as 5 matrix, 5 into a matrix plus 10 into a matrix, or you can simply write it as 15 into a, right? So these are the two properties associated with matrix multiplication, that is by a scalar. Now we'll try to understand matrix multiplication, very important concept. I will take two matrices. One is a matrix which is of order 2 cross 2. You should note down this order first, then and then only you will proceed with the multiplication. Here I am taking B as a 2 cross 3 matrix, right? So if you want to carry out this multiplication, that is A multiplied by B, then the column of prefactor and row of post factor should be equal, and then only you can carry out this multiplication, right? If the column of prefactor and row of post factor is same, then and then only matrix multiplication is possible. Now, before going to actual multiplication, you will write the order of resultant matrix. Means if you will multiply two matrix, then the resultant will also be a matrix only. So here the resultant matrix will be of order 2 cross 3, right? Therefore it will be of the form A11, A12, A13, A21, A22, A23, right? Always remember that we will use row of prefactor and column of post factor. So here this element is A1, row 1, column 1. So we will use row 1 of A matrix and column 1 of B matrix, and will multiply 6 into 2 plus 9 into 7. Row 1, column 2 will use row 1 of A matrix and column 2 of B matrix. Individual element will multiply, that is 6 into 6 plus 9 into 9. Row 1, column 3, row 1 of A and column 3 of B. 6 into 0 plus 9 into 8, right? Column row 2, column 1. So row 2, column 1. 2 2s are 4, that is 2 into 2 plus 3 into 7, row 2 column 2, 2 into 6 plus 3 into 9, row 2 column 3, 2 into 0 plus 3 into 8, right. So this is 6 2s are 12 plus 9 3s are 9 7s are 63. Therefore, the total is 75. 36 6 6 are 36 plus 9 9 is 81. That is, the total is 117. 6 zeros are 0 plus 9 is a 72. So total is 72. 2 2s are 4 plus 7 is a 21. So total is 25. 2 6 are 12 plus 3 9s are 27. So total is 39. And 2 zeros are 0 plus 24 will give me 24. So this is how we carry out our multiplication. Let's try to understand the properties associated with matrix multiplication. First is addition. Multiplication is associative, means if I am interested in multiplying three matrices, then I can do it in two ways. I can multiply first B and C, and I will multiply that resultant with A, or I can multiply A and B first and I will multiply that resultant with C. But in both the case, the answer will be same. That is, matrix multiplication is associative. Mind well, matrix multiplication is not commutative, right? The product of A into B is not equal to product of B into A, right? So matrix multiplication is not commutative, it is associative, right? You can apply distributive property, that is A multiplied by B plus C matrix will give me A multiplied by B plus A multiplied by C. And existence of identity means if you will multiply A matrix with identity or identity with A, you will always have that same matrix A. So these are the three properties associated with matrix multiplication. This much knowledge is enough to start our next exercise, that is exercise 3.2. Let's try to understand the very first question of your exercise 3.2. Here three matrix ABC is given. The order of A, B and C is same, that is 2 cross 2 matrix. Here we are first asked to find A plus B, means I have to add matrix A and matrix B. So corresponding elements will add 1 plus 2 will give me 3, 4 plus 3 will give me 7, 3 plus minus 2 will give me 1, 2 plus 5 will give me 7. Next question B. Second question is you have to subtract A minus B. So if I will subtract A and B, then 2 minus 1 I will have 1, 4 minus 3 I will have 1, 3 minus minus, that is plus 2 I will have 5, and 2 minus 5 I will have 3, right. Third is we are asked to find 3 into A minus C. So I have to form 3 into A. If I will multiply each and every element of A with 3, we will have 6, 12, 9, 6 minus C, that is minus 2, 5, 3, 4, right. So I will have minus minus plus, I will have 8, 12 minus 5, 7, 9 minus 3, 6, 6 minus 4, 2, right. In next question we are asked to find A, B and BA, but before that let me just confirm the answers, if it is correct or not. Yes, it is. So here we are asked to find A, B and BA. So let's find A, B. In fourth question we are asked to find A, B. So I will keep prefactor as this and post factor as 1, 3 minus 2, 5. So this is also 2 cross 2, 2 cross 2, column of prefactor and row of post factor is same, therefore matrix multiplication is possible, and again the answer will be of 2 cross 2. That is the resultant matrix is of order 2 cross 2. Row column 2 minus 8, 6 plus 20, 3 minus 4, 9 plus 10. Right. Now we'll compare this answer with the fifth question, in that we are asked to find BA. So I will rub this and we'll find BA. In fifth question we are asked to find B into A, so I will keep pre-factor as B whereas post factor as A, and we will multiply them. Again the resultant will be a 2 cross 2 matrix. Row column 2 plus 9, 11, 4 plus 6, 10, minus 4 plus 15 will give me 11, minus 8 plus 10 will give me 2. You can see that the result of 4 and 5 is not same. Right. So this confirms that matrix multiplication is not commutative. That is, the answer of AB and BA will not be same. Right. Let's compare the answers. AB is minus 627 minus 119, correct. This is also correct. Okay. Let's try to understand second question. We have 4 sub questions in that. Here we are asked to add, as the order of these two matrices is same, I can add corresponding elements will get added. A plus A, 2A, B plus B will be 2B, minus B plus B 0, and this is 2A. Right. Let's try to understand the second question, where it is given A square plus B square, B square plus C square, A square plus C square, and A square plus B square plus 2AB, 2BC, minus 2CAC, minus 2AB, right? So I will add corresponding element. I will have A square plus 2AB plus B square, B square plus 2BC plus C square, A square minus 2AC plus C square, A square minus 2AB plus B square. But I can write this as A plus B whole square. This is B plus C whole square. This is A minus C whole square. This is A minus B whole square. Right. Let's try to understand the third question. Here we have to apply the concept of matrix multiplication. Here the factor given is AB minus BA, whereas post factor given is A minus B, BA, right? So the resultant will also be a 2 cross 2 matrix. Row column will give me A square plus B square minus AB plus AB minus AB plus AB, B square plus A square. Therefore the answer is A square plus B square 0, 0, A square plus B square. This will get cancelled. Right. Let's try to understand the second question. This is 3 cross 1, whereas this is 1 cross 3. Therefore the resultant will be a 3 cross 3 matrix. Right. Row column 2 ones are 2, row column 3 ones are 3, row column 1 4s are 4, 2 2s are 4, 2 3s are 6, 2 4s are 8, 3 2s are 6, 3 3s are 9, 3 4s are 12. So this is our resultant matrix 3 cross 3. Let's try to understand the fourth question where we are asked to find the value of a plus b. So how to add a matrix A plus matrix B. So corresponding elements will get added. 1 plus 3 will give me 4, 2 minus 1 1, minus 3 plus 2 minus 1, 5 plus 4 9, 0 plus 2 2, 2 plus 5 7, 1 plus 2 3, minus 1 plus 0 minus 1 4. We are also asked to find b minus c. So I will find b minus c. 3 minus 4 minus 1 minus 1 minus 1 minus 2, 2 minus 2 0, 4 plus 4 minus 0 4, 2 minus 3 minus 1, 5 minus 2 3, 2 minus 1 1, 0 minus minus, that is plus 2, 3 minus 3 0. Right. We are also asked to verify the value of a plus b minus c is same as a plus b minus c. So we'll verify that. Let's add a and b minus c. So this is a, this is b minus c. So we'll add them. 1 plus minus 1 0, 2 minus 2 0, minus 3 plus 0 minus 3, 4 plus 5 9, 0 minus 1 minus 1, 2 plus 3 5, 1 plus 1 2, minus 1 plus 2 1, 1 plus 0 1. Right. And the next is a plus b minus c. So this is a plus b, this is c. I have to subtract 4 minus 4 0, 1 minus 1 0, minus 1 minus 2 minus 3, 9 minus 0 9, 2 minus 3 minus 1, 7 minus 2 5, 3 minus 1 2, minus 1 minus minus plus 2, that is 1, 4 minus 3 1. So if we will compare these two, then the answer is same, hence verified. Let's understand fifth question where a matrix and b matrix is given and we are asked to find 3a minus 5b. I have to multiply 3 with each and every element of a. You can see that the denominator of most of the element is 3, so it will get cancelled. So I will have 2 1 5, not 1 here, 3 ones are, it will be 3, 1 2 4 and 7, 3 2s are 6 and 2. Right. I have to multiply 5 with each and every element of b. You can see that denominator of most of the element is 5, so it will get cancelled. So answer will be 2 3, 5 ones are 5, 1 2 4 and 7 6 2. So if I will subtract, then it will be 0 0 0 0 0 0 0 0 0. Right. Let's understand the sixth question where we have to multiply cos theta with each and every element. So I will have cos square theta, cos theta sin theta, minus cos theta sin theta, cos square theta, plus sin square theta minus cos theta sin theta, cos theta sin theta. Here it will be. So if I add, then I will have cos square theta plus sin square theta plus minus 0 minus plus 0 and cos square theta plus sin square theta. But you know that this is the identity whose answer is 1. So final answer is 1 0 0 1. Let's try to understand seventh question where we are asked to find the value of matrix x and y, and the equation related to x and y is given. X plus y matrix is 7 0 2 5 whereas x minus y matrix is given 3 0 0 3. Right, so if I directly add this, then plus my minus y will get cancelled and 2x will give me 10 0 2 8. Right, so if I divide each and every element, I will have the value of x, that is 5014. Right, now you know that x plus y is this, so y can be written as 7025 minus x matrix. So 7025 minus value of x matrix is 5014. Therefore if I subtract these two, then I will have the value of y 2011.